So in this video we're going to talk about one of the most important technical aspects of photography, which is exposure. And exposure is basically mostly about how much light you are letting into the camera onto the light sensitive chip, or the CCD or CMOS chip, whatever kind of chip is recording the image. How much light are we letting in? That's the main part of it. There's also another factor called ISO, which we'll talk about, which affects the sensitivity of the chip, kind of like when you used to change film speeds. So the first part of this, exposure triangle is shutter speed. So shutter speed is how long is the shutter open, and the shutter is basically something that hides or shows or lets through or stops the light coming through the lens. Sort of covers or uncovers the CCD or CMOS chip. In a film camera, it used to be just a mechanical sort of slide that went up and down or across different kinds of shutters that would expose the film. But now it's digital, but it works basically the same way. Even though technically there may actually not be a shutter sometimes, it's just maybe how long do I want to expose this image for. So here's an example. Here's the same basic scene shot with two different shutter speeds. Shutter speeds are usually expressed in fractions of a second. So here's this tree at a 15th of a second. Here's this tree at 4 seconds. Different exposures, different lengths of exposures. So this one kind of looks blurry and soft because it moved during those 4 seconds. This actually looks a little bit blurry and soft too because it moved, but not as much during 1/15th of a second. So most of the time exposure shutter speeds are measured in fractions of a second, 1/15th, 1/30th, 1/60th, stuff like numbers like that. A couple of more examples how it relates to motion. So you can obviously see that shutter speed affects the representation of motion here. Here's another example. This is a bicycle rider, and this is at 1/30th of a second. We're pointing straight at him, and he's blurred because he moved that far in 1/30th of a second. Here it is at 1/500th, which is a lot faster shutter speed, and he's kind of frozen. So if you want to freeze action, like sports or something like that, you would use a faster shutter speed. Or another example would be if you're shooting pictures of kids or animals or pets that move a lot, you might have to use a faster shutter speed. Here's another example which we'll come back to. This image on the left, make this a little bigger here. This image on the left is a slower shutter speed. This image on the right is a faster shutter speed. This one's kind of in the middle. So you see the faster one kind of freezes the action. The slower one, they become almost invisible because they've moved so much during that exposure. Here's another sort of a little tip on shutter speed. Say you needed to use, for some reason, which we'll get to, you needed to use a slower shutter speed, like a 30th of a second. So we saw before, if you were at a 30th of a second and you were shooting something that was moving, but the background is, you're pointing straight at the background, the object moving will be blurred. If I wanted to shoot a similar picture without the rider being blurred, I would pan the camera with him. So now he is not moving very much in the frame, but the background is going to be blurred. So you get a different effect depending on if you're pointed at the background and not moving, or pointed at the rider and moving. Also, if there's not a lot of sideways movement, you'll see less movement from slower shutter speeds. The second part of the triangle is aperture. So aperture is basically the size of the hole in the lens that's letting through the light. So older lenses and some higher end lenses, you will see this sort of scale on the side of the lens even that will tell you what your f-stop is set to. So f-stop, this f number here, is the number that talks about how big that exposure is, or that aperture is. So this one is f2.8 here, which is the big hole. This one is f4, which is smaller, f5.6, which is even smaller, f8, which is even smaller, f11, smaller, f16, smaller, and f22, which is the smallest one on this lens. So each of these basically whole f-stops are let through half as much light or twice as much light as the one next to them. So for example, this is f8, kind of in the middle here. This aperture lets through twice as much light as the next whole f-stop, which is f11. It lets through half as much light as the next bigger f-stop, which is 5.6. One of the things that's a little confusing is the smaller the f-stop number, the bigger the aperture. The bigger the number, the smaller the aperture. So remember that. Small number, or big number, small aperture, small number, big aperture. So again, each one of these is half or twice as much light as the second, or the one next to it. F-stop is actually a ratio. So here's another example that the aperture may be actually, the physical size of the hole may be different. So here's a 50mm lens, which is a sort of a normal lens for a 35mm camera. That means it's about 50mm long. This 50mm part talks about how long is the lens. So you can see the hole is bigger than this one. On this 28mm lens, that hole is smaller. But they both say f8. Why is that? Because the f-stop number is a ratio. And if you can see it down here, I can magnify it here for you. If I can get that over there. F-stop is the lens focal length divided by the aperture diameter. The lens focal length divided by the aperture diameter. What does that mean? The focal length is, again, how long the lens is, how long it magnifies, which we'll talk about more as we go along. A telephoto lens is longer, a wide-angle lens is shorter. So that's the focal length. This one is longer. This is 50. This is 28. So this one has a longer focal length. The aperture diameter is actually how big it is. So here's an example. This one says f8 is equal to 50 over 6.25. So that's 50mm divided by 6.25mm. That is 8. Yeah, yeah, it is 8. So that is why we get f8. So this is just telling you that the actual hole in the lens for a certain f-stop may be different depending on how long the lens is. So that is the aperture. Another thing that aperture affects, which we'll have another video about, is depth of field. So here's the same shot, basically, shot with different apertures. So here we have f5.6, 8, 11, 16, 22, 36. Now these again are just like on this list we saw. These are whole apertures, 2.8, 4, 5.6, 8, 11. You kind of need to, well, it'd be good to memorize those. They are whole f-stops, meaning each one is half or twice as big as the one next to it. On your actual camera, you may see fractions. You may see 8.1 or 8.2 or 8.3 or 7.8. What that means is you're a little above or a little below 8. So more modern cameras can go in between f-stops. So that's what that means, is when you see those numbers like that. Right, so the depth of field can be affected. Depth of field is basically how much of the image in front and back of where I focused is in focus. What does that mean? Well, you can see this one is f36, which is a very small aperture. If I look at that image, the flowers in the foreground and the stuff in the background is fairly in focus. If I go all the way to the other end, you can see in this image the flowers in the very foreground are kind of out of focus. These are in focus, and these are way out of focus. So I have what's called a shallow depth of field, less depth of field. So I'm going to talk about this in another video because there's a little more to it than that. But you can see that f-stop affects depth of field. The aperture of the camera or the lens affects depth of field. This image is probably one of the best ones I know of that really kind of illustrates how this whole shutter speed aperture combination works. So here's 3 images again. It's 3 images of the same scene with some birds in it, and they're moving, right? So here's the first exposure. The first exposure is f16, which is a small aperture, and 1/8 of a second, which is a long shutter speed. So the idea behind these two, shutter speed and aperture, working together is, the way I like to think about it is, your exposure, say your proper exposure is a bucket. You can fill up that bucket more than one way. You can turn on the water a lot so that it fills up faster. That would be like a larger aperture and a shorter shutter speed. Or you can just turn on the water as a trickle, and then it will take a long time to fill. Same amount of water, different amounts of time. Same kind of principle here. So if I use a small aperture, I have to let the light in for a longer amount of time. If I use a big aperture, like f2, I don't have to leave it open as long. So I can have it open for a shorter period of time. So this one is f2 at a 500th, which is the equivalent exposure, basically, as this f16 for 1/8. Same amount of light. One is a smaller amount of light for longer. One is more light for shorter. Same amount of light. So, the strange thing about this is, all these exposures are correct. This is f11 at a 15th, f8 at a 30th, f5.6 at a 60th, f4 at 125. And I don't know if I pointed this out when I talked about the shutter speeds, but they're all basically half as much or twice as much as the one next to them as well, just like aperture, whole shutter speeds anyway. So here we have 1/8, 1/15, about half as long, 1/30th, half as long of that, 1/60th is half as long as that, 1/25th is half, about 250, 500, and so on. So they're all kind of equal, double or half of the one next to them, just like the apertures are double or half of the one next to them. So all these exposures for this scene are correct. But you get different effects, right? So this one is at a 500th of a second. You can see that the birds are kind of frozen in time there. Move this over a little bit. Because we used a fast shutter speed was used, they're frozen. They don't move very much in a 500th of a second. This one is 125th of a second. You can see that some of the birds are kind of blurry, some of them are kind of not. Depends on, their wings are more blurry than their bodies because their wings are moving faster, so that's kind of in the middle. And then this one is 1/8 of a second, and you can see they're pretty much gone. They've disappeared almost because they've moved so much in 1/8 of a second. So the other thing to notice is, again, the depth of field thing, which we mentioned a little bit earlier. This one, the background is pretty much in focus, or more in focus. This one, it's not. Right? Back here is out of focus, this is in focus. So when I use a smaller aperture, again, I get less depth of field. When I use a bigger aperture, I get less depth of field. Smaller aperture, more depth of field. Smaller aperture, but a bigger number. That's the confusing part, right? So that is showing you that you can. That's why it's important to have these controls, aperture and shutter speed, available to you when you do photography, so that you can manipulate this. Obviously, both of these are the same scene and the same birds in the same background, pointing the same direction, and they're both the correct exposure, but they're very different images depending on what you want to do. The last part of the triangle, and these two are the only ones that actually affect the amount of light coming in the camera, are the aperture and the shutter speed. The third part of the triangle, though, is how sensitive your camera is to that light. So you can change that. When we used to shoot with film, you would buy a certain speed for the film. So the film would need a certain amount of light to be exposed correctly. CCDs and CMOS chips and other kinds of chips in the backs of digital cameras, you can adjust the sensitivity. But there is a price to pay for that. So here is here's a cool little illustration of that. This is the DP Review website, which you've probably seen, and this is a camera comparison at high ISO. So ISO is basically the sensitivity of your camera or your CCD. So you can turn that up, which means you can basically see better in the dark. The problem with that is it does usually affect your image quality. So here's sort of a test image. and they shot it with a bunch of different cameras at different ISO settings. So here is the ISO. Here I'll set it to really low. So this is now set to ISO 125, which would be a pretty low ISO setting. And if you look at the image, it looks pretty good. This is the image itself, but if you blow it up, you can see the difference here. So here's the image close up. I can move this little rectangle around. Let's see. Let's look at this right here. Look at this area. All right. So there's the image blown up, and you can see what it looks like. So what we're actually looking for, what I'm getting at, is noise. Noise is kind of damage to the image usually from high ISO and or low light situations. So when you're going to see noises under low light, like you're shooting in the dark or at a concert or at night or in a dim room, that's when you're going to get problems with noise. And one of the reasons is you might have to use a higher ISO. So if I have my lens, remember if we go back to exposure here, let's say I have my lens all the way open, which means wide open in this lens would be f2.8. And then I have my shutter speed set pretty low, like a 30th of a second. I can't go a whole lot lower than that without using a tripod or if there's somebody moving in the shot, they're going to be blurred like these birds are, right? So what do I have left to adjust? I don't have enough light. I've got my lens all the way open, and I have a slow shutter speed. Can't go much slower or else it's going to be blurry, especially if I don't use a tripod. So the last thing that you can adjust is the ISO. So if I go up here and I change this I'll put it all the way up, and you'll see the difference. So there I just put it all the way up, and now you see the difference in the images. Here, I'll change one of them and you'll see the difference here. Let's change this one. See how much cleaner that is than that? This is the same camera, different ISO. So now it gets that noise. So these little pixels, you especially see it on this camera, those little pixels of the wrong color or different brightnesses, that's called noise. And that's what you're going to get at higher ISOs. So you want to, because of that, you want to avoid high ISOs because your image will look better. So how do you avoid it? Well, sometimes you can't. Sometimes you're in a dark room and you have to use a higher ISO. But try to avoid it. So another lesson for that is always try to use the lowest ISO you can. So your cameras are probably usually set on auto, which means the camera is going to use a low ISO in general until it can't anymore if you're on a program setting or auto setting. If you want to control that completely yourself, most cameras, which you'll see in another video, you can change it to a specific ISO and make it stay there. But that means you have to adjust other things, exposure, shutter speed, that kind of thing. So that is the third part of the exposure triangle, is ISO, which is basically the sensitivity of your chip. But remember, the higher their ISO, the more noise you're going to get, and the worse your image is going to look. So it is a trade-off. Okay, I think that about does it on exposure, and in other videos we'll look on how to actually set those exposures, control those exposures with your controls on your camera.